Okay, perfect. So this is a very simple website, right? It's just the text hello. So this is what it actually looks like, right? And then I can make this a little bit more complicated. So for example, let's say I wanted this text to be bold, right? There's a tag that's called B. So this part here at the beginning is like the beginning of a tag. So it means that everything that starts from here should be bold. And then you have the text hello. And then this like notation with like the slash closing means that everything after this should like ignore it, like it's not bold anymore. So let's say I did hello CID, right? When I refresh, cool, now it's bold. Let's say we want this to be a title. We want it to be a heading. You can wrap all of this again in this thing called H1, and now it looks like a heading, right? And then, so let's say we can create a paragraph. Paragraphs are P. We are a research institution. Real economists hate us. Right? Okay, and now you have a paragraph of text. So it's not super complicated. As long as you know what the tags are, if you have some cheat sheet, it's like not super difficult to start building more complicated structures from this. So let's take a look at this. Like let's say we have an ordered list, right? Okay, so let's make another paragraph. Molly's favorite desserts, right? And obviously, like number one's going to be baklava. Also pretty good. Okay, let's like get brownies or no pies, like awesome. And chocolate, right? Cool. So now I basically created this thing where OL means ordered list and LI is a list item. So basically every list item I wrap in LI, 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 and then I wrap all of those inside of an OL, and boom, I have a list of my favorite desserts, right? So we built a website already. Done, right?
And I can go online and I will find it.
You can, so there's like a little bit more effort involved in like putting it online. But so, I mean, this is running on my computer right now. So, okay, so see how it says localhost here? And then see how there's a colon and there's 8008. So 8008 is the port that this little website is running on right now. And then test.html is the file on that server that it knows, like that I told it to go through.
And what if you want to put a hyperlink to Google.com?
Okay, let's do that. So links are weird. They're called A for some really weird reason because they're called anchors. Because you can have like anchors and pages. So like for example, let's say you're in Wikipedia and there's like the table of contents, and you click on like the title and it takes you to that position. So that's what they originally were intended for. But then it like grew into, whoa, you can go into like other websites with this thing, right? And then href means hyper reference. This was made in the 60s, so they like their hyper, you know. Right, and so inside I can put the text of what I want it to be, right? So Google, and when I write it, here's our link, and when I click on it, we're at Google. So that's kind of what it is, but this is like kind of limited, right? Like it's like every time I want to change something, I have to like go to the website and I have to like type a bunch of stuff, and I have to kind of like build that, like rebuild the website every single time over and over again. So I want to show you a little bit more about the programming language that we normally use to basically create these pages. Yeah.
Why you don't need to put www before Google? It's like by default it assumes that.
Okay, so that's a really good question. So yes, that is correct. So Google has this setting, and almost every other website does, where if you go to google.com, it'll automatically redirect you to www. It didn't used to be that way, but websites became like so common and so popular that it is instantly assumed at this point that like if you go to a website, what you want is like www.
What would be the alternative?
So like our website, right? atlas.cid.harvard.edu. So those could be basically, each of those sections could be like pointing to different websites, right? So for example, can you guys see this? I know it's like a little small. So harvard.edu is one website, right? And then atlas.cid.harvard.edu is a different website. So you can add more stuff to the beginning of the name, and that means that like it's anything that's below Harvard, you can like, so anything that's under something.harvard.edu is like in harvard.edu. And so there's like kind of like this hierarchy of names.
CID.harvard.edu should work as well.
Oh.
Take off the Of course not.
Technically, it should. Good try. So okay, so I was talking about how these websites are like not too dynamic, right? Like, so I want to be able to have a source, like I want to be able to build these websites and make them happen kind of dynamically. So I'm going to show you a little bit more about the programming language that we use. So this is Python. It's not the most advanced language in the world, but it's nice. It's a nice one because it's like not super complicated either. So here's a valid Python program. I'm going to type into things, and the programming language is going to respond to me, right? So I typed 2, and it said like, okay, 2, right? So I typed 2 plus 2, 4. Okay, pretty good. 2 times 10, 20. Not bad. So there's a command called print. So I can say print hello. Gets me hello, right? So I can also have variables. For example, I can have a variable called my name. And let's say my name is Molly, right? So I can do something like my name plus is awesome, right? And now I get Molly is awesome. So you can then start here, and you can like keep going further and further. So here's a thing you can do. For example, what if I started doing this? So I can start like mixing the output of my program and HTML together, right? So, okay, let me give you a more concrete example. So let's say, okay, let's redo the list of desserts that I had. Let's say I like baklava, brownies, and, okay, pie. Okay, so desserts is now a list of baklava, brownies, and pie. So I can say for dessert in desserts, so there's a list of desserts. For everything in that dessert, I'm going to call that thing dessert, and I'm going to say print dessert. Okay, what did it do? So it printed baklava, brownies, pie. Pretty good. So now I can make this a little bit more complicated. So remember how I was showing you, sorry, I should have thought of this. So, okay, in our website, for example, we had the list, right? So if you wrap things in li tags, then you end up with this like pretty ordered list that we had here. So what if I did li plus dessert plus close li, right? So now instead of manually typing these things out one by one, I have a program that is like generating the HTML that I need for me. And so you can take this like several steps further. So I can then say, I don't want to like store these things in a program. I don't want to type them out like this, but I can store them in a database, right? Or I can store them in an Excel sheet, and I can have my website go through the Excel sheet, pull out all of the desert values that I have, create this website, and then dump it out. And that could happen when you go to the web page, right? So that is kind of like the fundamental part of
How
like,
does it go from this to the website? Because you showed how it happened on the other one.
Yeah.
This is the same. This is creating something on a website. Or it's just creating it here.
yeah, so it's creating it here. So there's like an additional step involved in like, so I created this text that is kind of like the source of the website, right? So then I would have to like save it into a file, or there's a way of not doing that. But then you'd save it into the file. Then when I go here and I refresh this, you're gonna have like the new values, right? So that's how you kind of like go further and further. And so
So hold on.
Yeah.
So at the end of your Python program, there is a command that says save file.html.
So that would be like a really simple, like simplistic way of doing it. So in reality, that doesn't happen. Like the content gets created, the program runs, and it immediately like shoves the result back.
Oh, and so you never that file, that's the one we're looking at right now.
Yeah.
Never exists.
It never exists. Yeah. So sorry, that part is a little confusing. But okay, so how is everyone so far? Questions? You need to ask me questions. No?
Maybe you could talk a little bit about the different languages. I mean, we know there are different languages for different things
Yeah.
on the web, but how do you, is it just a matter of somebody eventually decides to come up with a different language that does something else better, and then theirs just becomes accepted? And
That's actually pretty much it.
It's improvement
So-
in the current language.
Uh,
Like HTML and Python, they're parallel. Like
They're parallel, yeah. So yeah, you're right. They are parallel. They're also like they're good at different things. So HTML is good at like you writing basically what you think the website should look like, and then it turns it into like a visual website. So that's what it's good at, and it's not very good at doing anything more complicated than that. So Python is a general purpose language that is kind of like pretty okay at doing any kind of thing. And yeah, so it's exactly like you said, where there's different languages and people come up with different ones. Sometimes it's like requirements, right? Like languages that were invented like 30 to 50 years ago are not as easy to use as languages that were invented 20 years ago, 10 years ago, or now.
C plus a language like that.
Yep.
How many are there?
A billion. There's at least like 10 different languages that are like pretty common.
Around the world.
Yeah, but they're all like so usually you'll find that the concepts are similar. So what you learn in one translates reasonably well into the other. Like it's like learning Romance languages, right? You learn like the grammatical structure is different. They all have the case system, blah blah blah, right? And so it's kind of like that. And once you learn one, it's kind of
How does it turn from this to the online atlas? How do you make it?
right. Okay, so I'm getting there.
Just one question.
Yeah.
Two questions.
Two questions.
I mean, so you have what's generating the text that would eventually be read from a HTML language point of view is generated in the Python language,
Yes.
right? So, but how do you automatically go from HTML, because there should be something like run this other code in Python, return the text, plug it into this language, and now read it through HTML.
So okay.
How does the whole thing happen?
So so when you go in here, you'll notice that like even if this was generated, you wouldn't see any Python here. So all the Python stuff happens on a different computer. By the time it reaches you, it's all been like substituted and like the text has been put in the correct places. And all you get is HTML. And all that the browser does, like Google Chrome or Firefox or Internet Explorer does, is like render that.
So the programmer, let's say, creates the text in Python and copies that into the web page, and then it runs. But what's you're not calling Python, but
You are. So every time you go to the web page, right? So every time, let's say I go to the Atlas and I click on the visualizations page. So this basically just ran a Python script, which did a bunch of stuff, looked up a database, and it said, okay, like find me Gabon, and it found Gabon, and it like got all the data, downloaded it, sent that over, and now you're seeing it. So basically, it is running instantaneously. And so that's the beauty of it, is that like if we had to manually create all the text for all of the different variations of all the graphs that we had, we would like run out of storage space, right? So this way, when the second you go to the website, I can just create the thing for you as it's happening, and I don't have to like save all of them.
So if you right-click there and put view source code, that's the thing that was created by the Python.
Yep. So this was a thing that was created by Python. That's exactly it.
You call it spaghetti code.
When I say spaghetti code, that is when you build things in such. So you can imagine how it gets way more complicated, right? So this is like a really silly page, and this is like a reasonably complicated page, and so what happens is that your code starts getting really big at this point, right? And it's like thousands and thousands of lines. So it's even difficult to keep in your head like what part does what, and right. And it's also sometimes difficult to understand like the flow of what's happening. Like, you know, you're coming in, you're looking at some data, then it like jumps somewhere else, comes back, right? So that's where the spaghetti comes from, because it's all tangled up.
But the difficulty also comes from the fact that you have written it in a different language and has been transferred to Python.
It's not that it's a different language, it's that the person who was writing it didn't consider like other people, basically.
How
Yeah, yeah.
would you consider? Would you put it in sections and say,
Yes.
this is to make a tree map.
Yep. Yep.
This is
That is exactly what it
Yeah,
is,
with
right?
explanation
But the
to
thing
it.
is that like saying that right now is like easy, but the reality is that whenever we start building a website, we don't really know what we want, right? Like we're building the Columbia Atlas and we're still discussing like what's even going to be in the website, how it's going to look, like there's all these variations. So it's difficult to plan like the entire structure of the website beforehand. So what will happen is that you'll build something and then you'll realize, well, oh no, like actually we have to change this a little, right? And we have to like add this other feature, and we have to add search, and we have to add this. And then so you'll see that like suddenly it's like growing. So there's this like process of how code evolves and like gets bigger and bigger. And so that's really what causes the mess. So you have to like be like really kind of stringent in thinking about, like sometimes you add too many things, you have to go back and rethink, well, okay, like maybe like it doesn't make sense for me anymore to like read all of this data from an Excel sheet because it doesn't fit in an Excel sheet anymore, so maybe I should use like a real database. That's the kind of consideration that you
surely
expect.
there are programs to optimize programs that are fully written.
You can optimize the speed, but it's difficult to optimize how the structure, yeah. That would get into like artificial
But
intelligence
for instance,
domain.
reordering instructions, which is maybe part of the problem of, for instance, redundant loops that you have created that are not necessary and things like that. Wouldn't that be corrected mechanically?
So okay, so you're going into a little bit of detail. But, so yeah, I mean, the computer actually is super intelligent, and it does, like, optimize in certain ways. So that makes it run faster. But at the end of the day, I'm still looking at the code that I wrote, and not the code that the computer wrote. So I'm still, like, stuck with my own mess. Yeah.
So do you guys rewrite it completely from time to time, just to like
Well,
now that you
so-
have more definite structure, now let's restructure it?
Completely is like something that you usually like don't try to do. It's kind of like the nuclear option, but like sometimes you have to. So if you're kind of like very careful, then you can kind of like ease through the process, right? Like usually it'll happen. This will happen to startups a lot, right? There'll be like 3 people in a garage, right? And they'll start building this website, and it works great. And then suddenly they get funding, and they're like on the front page of like TechCrunch or whatever. And suddenly they have like 2,000 users coming in, right? And they didn't build the website to be able to handle that. So what happens now?
So how you just said, sorry, about not being able to handle it. What do you mean by that? So if something was created to work for 3 people, why would it not work for 2,000?
Okay, so that's a really good question. I'm like debating whether I should like wait a little bit later so I can like answer your question in context, and I think I want to do that.
Okay, I owe you then.
How long would it take you to do, for example, the Colombia Atlas website?
Well,
If you
by
get
current
the
calculation, it's gonna be 3 months.
Suspicious question.
It's gonna like it's.
I have no idea. You
Yeah.
might say a week, or you might say
So
a
I
year.
mean, there's like a lot of kind of different parts of the process, right? Like the actual building of it might take us like maybe 3 months or 4 months or something. But like there is then like the whole process of like figuring out what's even going to go in the website, like looking at all the data, looking if it's okay. So you know it kind of expands. And okay, so.
What is the ideal process though? It is like, think about it, you put it up, you approve it, but you try to be good about saying what you're doing, so that if somebody comes and it says, oh no, we want it all different, you know which part of the code to go to. Is that?
That sounds pretty accurate. Yeah. You want to be able to like, you want to have some idea of the kind of thing that you want. And so basically, I know like I'm building for change, right? Like I know that a month down the road, like we're all going to have different opinions about like what the blah 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 page should look like, right? So it's my job to consider that might change and to make sure that like we're not screwing ourselves over. Like we don't have to rewrite everything in a month after this or a year after this, hopefully, or 10 years after this. Okay, so how are we on time? Okay, it's getting kind of late. So, so here is basically what the actual, here's an example of what a website would look like, right? And how the connection would look like. So let's say we're in the Harvard network. This is my computer right there. And there's like Google Chrome running on it. And then here is basically another computer somewhere. And it's running Python. And it has a database that's like full of data, whatever. And basically, when my browser sends over a request, it's like, give me this page. And it responds and it sends me a bunch of HTML. And so this part that runs on my computer, we call the front end. And so that is usually what Gus and Roman do in our case, and what probably Quinn's going to do.
You're our only backend?
I am our only backend.
More.
And so my job is to figure out like how this stuff works. But there's like economies of scale working here in the sense that like once I figure out how to do like one of these things, right? Like I have figured out the code for the Columbia municipalities. The code for the Columbia departments isn't like that different. So it's easy for me to like kind of replicate what I'm doing, but it's like harder for the front end guys to do that just because of like everything they're building. Like I never have to see humans. Or humans never see what I'm doing, right? So that's like yeah. So here's what you do like when you get a little bit bigger, right? Like so you're seeing that, okay, like we're getting like a lot of users. So this is kind of like going towards your question where like we're getting a lot of load and the computer's getting really slow. Like if anyone's ever tried to load like a really large Excel file, it's like, it's like loading and it's like chug. You wait for like an hour and it doesn't really load. And then you're like sum and you wait for like another hour for it to like sum a bunch of numbers. So at that point you might say, okay, well maybe we want to take part of my system and put it on a separate computer, right? And so that's how you start building these, yeah.
So this is again going to the basics. So if I'm Mark Zuckerberg and I just created my Facebook page, and I tell my 10 friends, hey, look the website. What they're gonna do is that in their home they're gonna go www.facebook.com.
Yeah.
And that's gonna ask a request to my computer because it's my website. So it's a request. My computer does something and sends the HTML code. And then another friend does the same thing, and so my computer does and then sends.
Yeah.
And when it starts to grow the number of people, my computer starts to get really crowded with all the instructions from all the different people. That's
correct.
That's what you're saying. So,
Yes.
So I have to have another computer right off.
Yeah, that's exactly what it is.
But it's just because it is receiving an instruction and sending the HTML code.
Yes.
It doesn't compute anything, you're saying.
I mean, it could be. So, like, for example, we could have, like, we do a bunch of computation where, like, I don't know, we're calculating aggregates over departments or aggregates over continents or something like that, right? Like, so there has to be some number crunching. So again, you could like pre-calculate all those things, but now you're like running out of storage because you have to save like all the different variations. So it's always a trade-off between like doing computation on time versus like doing it beforehand and like saving all of it. So it's like you're trading space for computing power. And computing power is cheap, relatively. So
the actual generation of the graphs, once the whole thing has been designed, it generated where, in the front end?
So it happens in the front end.
In the front end.
In the front end. Because why does it happen in the front end? So let me show you. So for example, I click here. I click on rankings. And see how the page like blinked a little and it changed and it reloaded?
Yeah.
So I mean, we've got it down pretty good in the sense that like it's reloading pretty fast. Like it's kind of difficult to see. But like you don't want, like every time you, let's say I click on this drop down and the information is loading, like I don't want to wait every single time for my connection to go here, go across the Atlantic, go somewhere else, come back again. Like that's really wasteful. So it's helpful to have more of the interaction stuff happening on the front end and the kind of like the more computation data stuff happening on the back end. That's...
So just to clarify then,
Yeah.
the question of as you grow, so these 3 entrepreneurs, they don't necessarily need to change the front end. They can leave the same webpage. They might just need to get another computer or different servers.
That is correct.
So it's like the back end that needs to grow.
Yes. Yeah. Yeah. Because the front end is running on every single person's individual computer. And so that brings like an interesting point is that sometimes something, if you have 1 billion users, something that would be really complicated to calculate for 1 billion different users on your computer will be way easier when you push that computation down into their computer, right? Like, so you can have that calculation happen on my computer instead, and suddenly you're not paying $1 million a year having to do that. So,
yeah, but then there's the trade-off between the speed of the front end and the speed to go back and forth.
Exactly. So you can't do that too much because then, like, if people have slow computers, then it's going to be a problem. So again, it's like all a matter of like all these different considerations.
And they also need to have the right software to do the computation. So
That
when
is
people,
correct.
the computer tells you need a plugin, like a Java plugin or something.
Right. Yeah.
So, but then even these are iPhones and things like that considered front end, I suppose.
Yeah.
Okay. So and obviously they are much less capable than the big computer that you have in front of you.
Yep.
So that means that if you design for an iPhone, then you are really sacrificing a lot because most users would be using the front end, the big computer.
That's a pretty good thought. But what you can actually do is you can build it in such a way that like I can detect that you're like a mobile device, and then I can say, okay, let me show you like a less detailed version of this. Let me show you like a less complicated. I'll like disable all the animations, right? Like I won't do anything too fancy.
And all that is done in the same program. It's not that you have different programs.
Yeah. So no, that happens in the So it used to be back in the day that there were like different programs to do it, but now it's going towards this thing called responsive design, where you want to scale like your website for like how big the screen is, right? Like as the user looking at it on a projector, on a computer, on a tablet, on a phone.
Yeah.
So.
Okay.
Okay. So then this brings us the question. So where the heck is this thing? So where is the server, right? The cloud. Dun, dun, dun. Okay, so the website is running on a computer Well, actually, we don't know if it's running on a computer. It's running somewhere. I've never seen the computers that run our code, right? And actually, no one has ever seen the computers,
exactly.
right? And it seems to exist. So that's all I can say. There is a thing that is behaving like a computer that is somewhere on the internet, right? And I willed it into existence.
Well, we have paid for it.
And you have, that's true. That's true. That's true. So, okay, so does anyone notice something weird about this picture? So, on the bottom you see like the little dock thing that Macs usually have, right?
Yeah.
But then over here there's like the Windows symbol.
Yeah.
And you're realizing that there's like an entire different computer running inside this computer. So you can have computers within computers.
Most people know that here as the cluster.
Yes, correct. So yeah, so that's one example. So the cluster's slightly different because it's like running somewhere else, but it could also be physically running on your computer. So like what a computer actually means is like kind of a, it's not really necessarily, it's getting a little philosophical here. But the point is that like I can then, like if I wanted 5 different computers, I could like start another one of these programs and have like another thing of Windows and another thing of Windows, and it's limited only by like how much processing power this physical device has, right? And so here is a data center. So this is Facebook's, I think. This is one of many, many, many data centers that Facebook has. So these things are like racks and racks and racks of computers. Like there's, I think, like 30 of these down. They're like 2 in a row, and then there's like 4 of them, right? So this is like a few 100,000 maybe, or 10,000.
All of those seems to.
Right, and it kind of looks like this, and I don't think it's a coincidence. But I was gonna do a demo, but I was gonna go to the Amazon Web Search thing and click a button, and it was gonna like launch a website. But I think I should like keep going and fill your time with something more interesting. So why do we care about this though? We care because we can scale up to demand, right? So for example, our website is like chugging along, it's doing fine, we get a bunch of different users, and then suddenly we get posted on the New York Times, right? Like what do? So we would have to, so right now what we would have to do is we would have to start like a bunch of new different computers. So I'd go to Amazon Web Services and I'd say, give me another computer. And then I'd, put another copy of the database there or something like that, right? But so here's what Twitter did. So they have the system where, they're doing something like 10,000, they're serving 10,000 users per second. And then something happened. I think it was like a film release in Japan or something, and they suddenly spiked to 150,000 requests per second. And then a few minutes later, they spiked all the way back down. So this is like technologically amazing, because what this means is like you can't, like, if this little peak here required 5,000 or 10,000 or 20,000 computers, then like back in the day you would have to run 20,000 computers all at the same time, right? And most of the time they'd be idle, they wouldn't be doing anything, and they would be only there purely to satisfy the possibility that this might happen.
So what happens if you cannot satisfy?
So then you like hit the enter key and you're just like waiting, and you're like, ugh, and then you hit the refresh key and you like send another request, and like the poor little computer over there is like trying to like respond to you, but it can't because it's like swamped, and that's what happens.
So it's really the nature of the users who have forced them to, because we freak out if something takes 5 seconds to load, then we move on.
Exactly.
So they have to prepare themselves for the worst case scenario at all times, or else they know whom their reputation is shot.
Exactly. And it's not even just the reputation. So Google did some numbers where they found that like I think if a website, there was like under a second, there was like something like a 300 millisecond delay can cause like a 20 to 50% reduction of like the chance that someone will buy something, right? So this matters for business, right?
And is that regardless of your computer and its abilities, like the speed of the computer?
computers.
Yeah, this is because my computer is not doing much, but like their computer is doing a lot. So it's really all about their computers.
Even if I have like multiple programs running at the same time.
Oh,
If I was using multiple programs, would that affect the speed of the website or whatever?
I mean, it wouldn't affect it would affect like the speed of like how you perceive the website in the sense that like it would affect the portion of the website, the front end that's like running on your computer, but it wouldn't affect Twitter or whatever. And so the consequences of this is that tiny teams can run big websites, right? Like so, for example, Instagram, the app that you can take photos of things or whatever, has like a bajillion users, and they started out as I think 3 people, and right now they have like 10 people, right? That's the entire website. That they're 10 people and they're running like thousands and thousands of computers. So and they're automating all of it. So that's like a really important thing. That's like a ridiculous cost savings, right? This was unimaginable. So there's no field maintenance. Yeah.
Sorry, but I didn't understand. So those peaks of peak usage.
Yeah.
When you said that it's auto scaling.
Yeah.
Means that they have. How do they do that? They have a way to go to Amazon and say, "Give me." I mean, no, I don't understand.
Yes. So what happens is when you're going to the website, like let's say we're all going, we all start tweeting or whatever, and then Twitter's like, like okay, number of like tweets increasing rapidly, got to do something about this, like reaching capacity, and then it just starts spinning up new computers, right? And there's like more and more of them. They're like all coming alive as you're connecting, and then when they come alive, your connection suddenly like flows through them, right? So there's like a.
I mean, they do actually have these massive banks of computers in warehouses in
Right.
the desert in Nevada and stuff. You know where they have the alien sites? This is actually like giant computer farms.
Sure.
Thousands and thousands
Yeah.
of computers.
But you just said that before you would have before like years ago, you'd have to have those computers there being idle just there.
Yeah.
These are just like
But
the central
now-
banks. I mean,
So
As opposed to what?
They're
So
still
okay.
there.
So what I meant is
there's
that
resource.
those computers, so these computers, so I don't have to be running these. All I have to be doing is purchasing time. So right now, for example, Amazon has this thing called Amazon Web Services, where basically they're renting these computers. They're selling them by the hour, I believe. So I can pay like 10 cents per hour to like, I don't know, a few bucks per hour for a ridiculously monstrous computer. And then I can shut it down whenever I want, and it's just on demand. Right? And so I never have to go to the field. I never have to see a computer. I never have to plug something, unplug something. I never have to worry that something broke. I never have to worry about anything.
So, and you can set an agreement where you say, just give me what I need when I need it. So it could tell you when there's a million users of the Atlas and give us 10 more
Yeah.
servers.
So I mean, it becomes like so doing
Have a portfolio.
this is like way more complicated. So I mean, like you could do it if you really want to, but then there's like an additional cost to building that infrastructure. And it's like if you don't need it, then it's not worth it.
So what for us is like, oh look, it's becoming slower. It must be we're getting a lot of users.
Yeah.
Let's buy more.
Yeah.
Click.
Yeah.
I mean, the rest of the space is typically used by like big institutions that do massive computing in the
Right.
downtime for cheaper cost.
Right.
So they have, say for example, NASA or something, or these big research projects that do supercomputing. They might use all that spare capacity when say Twitter is not using it, but it's there.
Right. So again, like it's the physical computers don't necessarily map very well at all to like what companies or people or whatever are using them. They could be anywhere.
So there is a risk that Amazon faces, which is it is possible that several of their clients have their peak at the same time.
That is true. So that's what a service level agreement is for. So you have an agreement with Amazon and you say, I want 9 nines of reliability. What that means is like, I want 99.99999% of all the time I want these websites to be up. And so different levels of reliability come at like different levels of cost. And so Amazon then decides whether it's worth it for itself to build the correct infrastructure to make sure that that reliability exists, right? So it could have different copies of all the computers. They're spread geographically. They're all connected with like different cables. So like one of them could go down and the other one could be alive. I don't know, some part of the country could get nuked, but it would be okay because the other part of the country would be like fine and the cables would be fine. So.
But they have had like Africa lost internet a couple of times last year because there's only one cable.
It happens.
So like it's one of these kind of impending.
And so Amazon Web Services actually has gone down before, and it took a lot of websites down with it. So it took Reddit down, it took Netflix down, it took bunch of other big websites that I can't really remember, and that's when people were like, well, oh crap, like we can't really, start relying on this. So then people started paying more attention to the fact that, okay, like what happens if Amazon goes down? What happens if,
I think my question is along the same lines, but I've heard before that, so say you have a server, this is what we're talking about, right? This computer is your server? This computer that you might be renting from Amazon?
Yes, that is my server.
And so I've heard that you need to patch it, so you need to maintain it somehow. What does that mean? Like, do you physically then need to create some updates to that computer, or does Amazon do that?
So there's different levels of managedness, right? Like, so what we're doing right now is we're buying a computer, and then the responsibility of like keeping it updated is down to us. There are also services that where you're not renting an entire computer, you're just renting like a program running on the computer. That's all you're renting, and you don't necessarily know like what else is there running with you. You can't really access it anyway. But they manage like all of the details of doing the updates and all that stuff. So it depends. And so I think what you're talking about is like usually security updates is a big thing. So when someone finds a security vulnerability, you want those updates to happen automatically. And so we have some infrastructure set up that handles that. When they come out, they just get pulled and installed.
So because we're at, do you want to finish, and so that when we know the topics that we don't.
Yeah.
Know?
Okay. Okay.
We know the topic of the next.
So I'm gonna go a little bit faster then. So there is basically, so you don't have to do field maintenance. So I don't have to go down to someone else, like go down to some blah blah blah's office. I can fix things on my computer, and I have access to it at all times. The other thing is like, what if we could have really so I could, at this point, the power of this computer doesn't really matter anymore. So I could have like a really old computer, but as long as I have a server on the cloud that is running whatever program I want, Stata, Photoshop, whatever, as long as that thing is as powerful as it needs to be, I'm good. So usually, in general, in the cloud just means not on your computer. It means on someone else's computer. It's a shortcut for that. Okay, so big data. I want to give you a scale of like how big things can get. So here's a Word document. So usually we measure the sizes of things on computers of data in megabytes. So 1-2 megabytes is a Word document. A song is like 5 to 10 megabytes. A large presentation could be like 100 or a few hundred megabytes because there's like a lot of pictures and videos and all this stuff. And then a data set that we use that's like municipality level is like 1 gigabyte, which is 1,000 megabytes. Okay, so we're going up in orders of magnitude. The largest data set we have, which is like the PILA, the Social Security data, is like I think 8 years of 20 gigabytes, which is like 160.
The telephone postman?
Hmm?
The telephone postman?
Oh, I forget how big that is.
I think that's larger.
That's larger?
Yeah.
Okay. So the largest hard drive I can buy, like I can go to a website and buy with a credit card today, is 8 terabytes, which is 8,000 gigabytes. So that's, a few orders of magnitude larger than that. Now, data transfer that happens within a single second in Google, between Google's computers, is 40 gigabytes per second. So it takes them 8 seconds to transfer enough data that is like the size of the largest data set that we have, right? So the largest cluster that Google has is around 5 petabytes, which is 5,000 terabytes. So thousands of times more, multiple orders of magnitude more, right? And then all the data that Facebook has is, by the most recent count, around 400 petabytes, right? Petabytes are 1,000 terabytes. Terabytes are 1,000 gigabytes. Okay, so just to give you a scale, if you wanted 10 gigabytes of data and you had a bunch of hard drives and you stacked all those hard drives on top of each other, So that's the Empire State Building. That's the Sears Tower, Burj Khalifa. And that's all the hard drives you would need to get 10 petabytes. And Facebook has 400 of them, right?
But isn't that law that now it's gonna be half next year or something?
Moore's law. So Moore's law is BS, but that's a different conversation. It's a pattern, but it's not necessarily a law. But yeah, you're absolutely right in the sense that the storage capacities increase over time. So, okay. So then let's say they increase over time. Who's gonna take all that data and put it all on the new drives, right? So that's like there's like so very simple questions when a data set is like on your computer in an Excel sheet becomes super complicated at this point, right? Like, so where is the data point I want? I have like, I don't know, 100,000 hard drives. Like, where the heck is it? So this used to be a simple question, now it's a complicated question. What is the current value of something, right? So let's say I have a bank account and my bank account has 20 bucks in it, right? So you, let's say you're giving me some money and then you're also taking money simultaneously. So there's like relativistic effects, right? Like in the sense that before him giving me money is completed, you could take money away from me, right? And so there's like a lot of difficulty in handling like stuff that happens concurrently. Or like, does the data point I want even exist anymore? Or like, how do I even make sense of all the data that I have? How do I even go through, begin processing this, right? Like, how long does it take for us to do like a single processing of the PLA? Let's say we want to, I don't know, aggregate it once, like an hour, 2 hours. Okay, so that's a reasonable number. That's for like 1 year, right? And so we're asking Google to send us a piece of information from this gigantic pile, and we want that exact piece of information, and we want it in under a second. We want it under a tenth of a second, right?
Mali, how much redundancy is there in the
That's a really good question. So usually 3 is an accepted number because you never want to be in a situation where there's only one copy that is left.
Yeah.
So usually it's like 3 of them, and they're like all in like different geographical locations, different physical locations.
And do you pay differently for that, or is that a decision that is taken by Google? Let's say.
I mean, Google manages all of their own, and you know they're just so good at it that.
So before you go on, well, this is just a matter of convention. But what would you say it's big data starts? What I mean, what's the size?
Big data is data that is impossible to process on a single computer, right? That's what big data is. So you can't just load up this, or you can't just load up the computing cluster and run it on one computer. It is just impossible for it to physically fit, and so that comes with its entire different set of problems. So now it's on multiple computers. So now how do you do like a thing, like how do you query some data off of like multiple different computers? How do you do that efficiently?
Yeah, but what's more or less the size? I mean, because I could connect, I have 4 USB ports, I buy
Well, he
8
said that
terabytes.
the size of that thing you can buy on Amazon. Is that
Yeah, so I mean 8 terabytes is like, I think anything over a terabyte is like, it's reasonable to call that big data, I guess. But again, like the physical number doesn't matter, and it's going to change over time, right? Like computers are going to get more powerful. It's really the idea that your data is spread all over across the place, right? So like imagine this, you have all these computers, all these hard drives. Now, hard drives fail. They fail very often, right? Like, so how do I have some piece of computation running, and it's like still running, and while it's running, a hard drive fails, the computer system dies, some network connection dies, and the computation survives. It like comes out the other side, and it's like still working. So that is like an insanely difficult problem. Okay, and then I had this like some stuff on how is this even possible, but it's back to the same thing where like you're adding more computers, and then suddenly there's like all these different limiting factors, right? Like so now if you have too many computers, then those computers have to communicate, right? So now the limiting factor is how much data you can shove through a connection back and forth, right? Like how fast can it get there? That becomes more and more difficult. And so people came up with these like different ways where you select different services. So you say, I have a cluster of computers somewhere that deals only with users, and I have a cluster of computers somewhere that only deals with emails, and I have a cluster of computers somewhere that does this other thing. And so you have these separate little services, and that's usually how companies are dealing with this. And there's like, it's not this simple, obviously. There's like a lot of thought that goes into like how this all comes together. So like here's an example of the architecture of Netflix. Like here's all the different services they have. Each of these services are like composed of different computers, and all the services interact with each other in a certain way. So like here's an example of when your connection's coming in on one side, it's like going through this one computer, and then like some of them go to this other computer, and then some of them go to this other one, and some of them end up here, and some of them end up here. So they can literally like sit and watch the data just like coming in like as a massive torrent, and they can see like which parts of them are like over capacity and under capacity, and like it really becomes this like big problem of like just data flow. And you can have computers on different parts of the world, and it's like because you don't want your users in Africa to be like waiting for hours while your users in the US are like fine and dandy. And so the internet is pretty ridiculous, right? There's no central authority that governs the internet, right? There's no central transit system. It's all, everything is connected to everything else. No one really knows each other. You've never talked to or seen, or even previously you've never communicated to any of the computers probably that you've communicated with today, because they're not real and they keep like dying and respawning, and it's kind of amorphous. And so imagine that you're like building this airplane, right? Like I don't know, a Boeing 747 is seen as this like miracle of human engineering, right? Like 20 different countries came together and everyone built this like separate little part, and then somehow it all came together and it flies, right? So imagining building this thing where there's no boss. Some people kind of know what it should look like, and there's no specification for like what all of it actually should look like, right? Like all the way down to like how the cables are sending all the numbers, and how the wireless happens, and how then it goes through Harvard, and there's like a bunch of computers, and then it goes through fiber optics, and then it goes to space, and it comes back down again, and it goes across the ocean, and it goes across to the other thing. Like all of these things are developed independently, right? And no one knows how all of it works. There is not a single person who even knows how most of it works, right? So there's like, usually you could spend your life like building like the Wi-Fi thing, like the Wi-Fi card in that laptop, right? Like that's how complicated it is. And so no one can force anyone to follow the rules, right? Like so even if you came up with a specification of like how the entire internet should work, like no one's going to listen to you, right? So and not everyone agrees on how to build things anyway, right? So there are these people who are coming up with like different ways to send data and like different data formats, and like I don't know, a company builds this like new thing and they say no, we're going to send music files in a different way. And the parts change without notice, and people decide to build their own parts, and most of the people never met each other who are designing this thing, right? And most of the people never even talk to each other. It's kind of emergent, and there's no top-down quality control, and things break all the time. But somehow it survives, right? And it works. Like, that's the amazing thing, is that, like, by golly, this thing works, and, like, you can drink your latte and, like, check Twitter and walk down the street without even realizing that, like, this is happening, right? And the other amazing thing is that we're building the airplane while it's flying, right? Like, at no point can all of this stop. It must keep going. The show must go on. Like, and, you know, if we want to upgrade everything, we must upgrade it while everyone's watching, while people are still using it, right? So imagine that someone said that, okay, we're going to build something bigger than the Empire State. And then they're like, yeah, but we're going to build it on top of the Empire State, right? You're like, oh, that's like a kind of a weird engineering thing, right? Like, but this is what we have to do all the time, and that's why software engineering is difficult. That's it. I know.
So I once saw.
You guys can. I know it's been over time, so you guys are guilty. No worries.
Can you teach us how to hack next? Do some hacking?
So I once saw that someone reconstructed, I don't know how, that's the question, how the internet was in 1986, something like that.
Yeah.
They were able to, I don't know where that information was, that they were able to reconstruct a picture of what the internet was in
Okay.
1986. So how would that work? I mean, where is that information?
Sorry, well, this is weird. Anyway, where is that info?
How were they able to do that?
Honestly, I have
It's
no
like,
idea.
oh, this was really hard, but we were able to reconstruct the internet, which has a few hundred thousands of websites in 1986. And this is it. And so you go there and you actually, they even, I don't know.
I have no clue. I really have no idea how that works.
Exactly. So,
Right?
Maybe someone had a recording.
Felipe, what is Java?
So that's another programming language, kind of like Python.
And what is the deep
But
web?
there's just this giant uncertainty.
Deep web. So that's like a kind of like a weird. It's another like kind of buzzword term, kind of like like big data.
I heard it's something that you cannot access with a regular browser.
Right. Yeah. So it's basically like kind of this portion of the web where it's like it's kind of hidden from everything. And it's not like a thing. It's just like a bunch of different.
Where is it? Is it also like in Google servers, in Amazon servers? Because I've heard like a lot of illegal activities go on there, so I don't think.
And you want to do them, obviously. So
Amazon.
you're asking me how to do it.
Amazon is not bad. I mean, hackers are usually there.
Yeah, yeah. So like the way it works is that so there's all these different ways where you can. Okay. So let's say you're connecting to your bank's website, right? So you're typing bankofamerica.com, right? How do you know that anyone in the middle isn't listening, right? So there are all these ways where you can encrypt the communication. So you can encrypt over here what you're sending and send it over, and the bank like decrypts it and looks at the contents and then encrypts it again and sends it back, right? So then you can take this and make it a little bit more complicated. So there's this system called Tor, for example, where it's a bunch of different computers, right? And let's say I want to connect to Juan, and you three guys are all computers on the Tor network. I'm not connecting to Juan directly because that would be suspicious. What I do is I connect to Andres, and Andres connects to Mate, Mate connects to you, and so on. Right? So the connection bounces in between, and the whole thing is encrypted. So at no point does anyone within this entire process know where the data came from and where it's going. Exactly. So they know, like, so Andres knows that it came from me, and then like you know that it's going to Juan, but you don't know that it came from me, and Andres doesn't know that it's going to Juan. Everyone just knows like one step ahead.
How many apps are there in this
But
store?
So the thing is that people are finding that this is like when you're dealing with governments, it's like kind of difficult because the governments have and do watch all of the ends of all the resources, and then that you can then kind of like reverse engineer some stuff, and you can from the timings figure out like who's sending or who's receiving. But anyway, so the deep web basically works that way in the sense that I could be running on a web server, and instead of you connecting directly to me, you're connecting like through Tor and coming out the website.
But the web servers are, I mean, these are like illegal web servers.
I think I really want to.
The content,
You can't have a legal machine. It's like the
I mean, the contents are stored in not in like in regular ones. It's not like
how do you know?
Amazon. In their things, they have deep web content.
Who knows?
It could be.
Like
Yeah, I don't know. It's,
well, that's the beauty. It could be anywhere. That's kind of.
But it doesn't have to translate.
One question about the cloud server.
just curiosity, when I was doing, for example, a parallel program, that a small code, not a big code, like 3 lines that I run in my computer, it takes, for example, a week, the whole time. If I send it to the cluster, or more specifically when I was comparing it to the parallel programming, and I say, okay, the slaves have to do I say 10 slaves. But it's just the same code. And then when I send it, it takes 1 day or 10 hours. So my question was like, because at the beginning I thought it was like a big computer who did everything, and it's actually the TED computer, but how did it distribute the same code across, across because it's like they can't do one step later because it depends on the one before.
Okay. So that's a really large open problem in computer science. Is that how do you take a regular program and figure out which parts are parallelizable? So there are like all these formal methods that you can apply, where like, so for example, some programming languages have this feature where
Yes, they got told us. And also unfunded.
where okay, so some things depend on something else, right? Like, but the computer is running all of them,
I don't know.
so it can basically figure out at every point which variable is getting modified, right? Like, so let's say there are some situations where, let's say you have a big table or you have a big data file, right? And you're gonna run column A plus column B equals column C, right? That's what you're doing. So none of the columns depend on each other. So it looks at that and it basically figures out and says, okay, well then I can parallelize those.
You can take, for example, 1 row, 2 rows, every row, for example.
But it's based on the program.
Okay. Okay. Man, it was great. Thank you.
Yeah.
Awesome.
Yeah, that's very interesting. Do you know about this quantum?
You should do another one.
So
is it like really something real, or?
Yeah, it is real.
I read about Google.
We're building quantum computers right now, and the thing is that the amount of data they can process is very tiny. Like they can, I think the largest one can process like 8 bits. So that's 8 zeros and ones.
Yeah.
That's the maximum it can do. So, but they're really interesting. Like they do computing in ways that we didn't think was possible, and they break certain things. Like
Some of the algorithms.
so like for example, I was talking about like encryption, right?
Yeah.
A lot of encryption depends on the fact that prime numbers are difficult to factor.
Yeah.
So like, which prime number, like, what are the prime factors of 200? It's like 2 and 5, right? So that's an easy one. But when you go to like numbers that have millions of digits long, that becomes way harder. And so you can use that to like come up with this encryption scheme, but then quantum computers, it turns out, are like very good at doing exactly that, and that like breaks encryption. So you have to come up with like new ways to do things, and so yeah.
Wow, that's really interesting. Yeah, that's great stuff. There are also these people who control like millions of computers, right? In Russia,
In
they put
Russia?
a virus, and then the virus spread